Venus is the second planet from the Sun, and it is the closest thing to hell that physics can build. On its surface, the temperature holds steady at 465 degrees Celsius, hot enough to melt lead, zinc, and tin into shimmering pools. The atmospheric pressure crushes down at 92 times that of Earth, the equivalent of standing nearly a kilometer beneath the ocean. The air itself is 96% carbon dioxide, thickened into a fluid so dense it behaves less like a sky and more like a sea. Above the surface, clouds of sulfuric acid drift at 250 kilometers per hour, raining a corrosive mist that never reaches the scorched ground. There is no relief anywhere. No mountaintop is cool. No night is cold. The heat is total, absolute, and unforgiving, radiated back by a runaway greenhouse effect that trapped this planet in perpetual furnace centuries before humans existed. Sunlight barely penetrates. Standing on Venus, you would see a dim orange gloom, the daylight filtered to the color of a dying ember. Metal softens, rubber vaporizes, electronics fail within minutes. Every material that keeps a machine alive begins to surrender the moment it touches this world. And yet, in the darkest years of the Cold War, a nation looked at this impossible place and decided to photograph it. The Soviet Union, locked in a technological rivalry with the United States, chose Venus as its battlefield, not to conquer it, but to prove it could be seen. The ambition bordered on absurd. To build a camera that could open its eye on a surface that destroys eyes. To send a radio signal out of a pressure cooker. To land a spacecraft, take a picture, and survive long enough to send that picture 41 million kilometers home. The odds were catastrophic. Most attempts would end as silence, as crushed metal, as machines that melted before they spoke. But the Soviet engineers were not starting from nothing. They were building on a decade of ruined spacecraft and hard-won lessons, a long lineage of failure that taught them exactly how a planet kills. To understand Venera 13, you first have to meet its ancestors. The Venera program began in 1961 as a graveyard. Venera 1 launched, then fell silent 7 million kilometers from Earth. Venera 2 died on approach. Venera 3 became the first human object to strike another planet in 1966, but it transmitted nothing, crushed to silence before it reached the ground. The early landers were built like divers who did not know how deep the water was. They assumed Venus might be survivable. They were wrong. Venera 4, in 1967, transmitted data as it descended, then went dark long before touchdown. Flattened by pressure, the engineers had drastically underestimated. Each failure taught a brutal lesson written in destroyed hardware. The atmosphere was denser than predicted. The heat was higher. The pressure was crushing. So the designers redesigned everything. Venera 7 in 1970 became the first spacecraft to transmit from the surface of another planet, though it landed on its side and sent only a faint, garbled signal for 23 minutes. Venera 9 in 1975 returned the first photograph ever taken from the surface of Venus, a single grainy black and white image of scattered rocks. The chain of failures was becoming a chain of firsts. By the time engineers at the Lavochkin Design Bureau began building Venera 13, they had learned to fear the planet correctly. The heart of the spacecraft was a titanium pressure sphere, a sealed vessel engineered to hold Earth-like conditions inside while hell pressed against its walls. Its interior was packed with lithium nitrate, a material that absorbed heat like a sponge, buying precious minutes before the electronics cooked. The whole descent module was wrapped in thermal insulation and pre-chilled before entry, sent into the furnace already cold, hoarding every degree. On top sat a ring-shaped shock absorber to cushion the landing, and a suite of instruments, color cameras, a drill, spectrometers, and sensors to read the air. The engineers gave it a design lifetime of just 30 minutes on the surface. That was all they dared promise. 30 minutes to open its eyes, take its pictures, drill its hole, and speak. But first, the machine built to survive hell had to travel 4 months and cross 41 million kilometers of empty space to reach it. On October 30th, 1981, Venera 13 lifted off from the Baikonur Cosmodrome atop a Proton rocket. It weighed roughly 760 kilograms, a compact fortress of titanium and instruments bound for a world that wanted it dead. The launch was flawless. Within hours, the spacecraft had escaped Earth's gravity and settled onto its interplanetary trajectory, a curving path that would carry it inward toward the Sun and across the gap to Venus. The cruise lasted 4 months. For 122 days, Venera 13 coasted through the vacuum, its solar panels drinking sunlight, its systems checked and rechecked by controllers on Earth. There was nothing to do but wait and drift, correcting the trajectory with small engine burns to keep the aim true. A miss of even a fraction of a degree across 41 million kilometers would send the lander skipping off the atmosphere or plunging in at a fatal angle. On March 1st, 1982, the moment arrived. The spacecraft split in two. The cruise stage, which had carried and protected the lander for 4 months, separated and flew on past Venus, becoming a relay station to catch the signals from below. The descent module, the pre-chilled titanium sphere, turned toward the planet alone. It struck the upper atmosphere at roughly 11 kilometers per second, faster than any bullet. The impact with that thick carbon dioxide air was violent. The module decelerated with brutal force, subjecting its interior to gravitational stresses far beyond anything survivable by a human body. Its aeroshell glowed as friction tore at the outer surface, a fireball punching downward through the cloud decks. The deceleration peaked, then eased. The sphere had survived the entry, the most violent phase of the whole mission. But it was still 60 kilometers above the surface, falling through layers of sulfuric acid haze, the pressure climbing with every second, the temperature rising toward the lethal furnace below. It needed to slow down. It needed to steer its fall into something gentle enough to land. And so, high in the orange gloom, the parachutes were about to deploy, beginning the most delicate descent ever attempted. At about 47 kilometers above the surface, Venera 13 released its parachutes. The aeroshell split open, and the canopies bloomed in the thick Venusian air, catching the dense atmosphere and jerking the descent module into a slower, controlled fall. For several minutes it drifted downward beneath the fabric, sampling the clouds of sulfuric acid, transmitting data upward to the flyby stage waiting overhead. Then, at roughly 50 kilometers altitude, the engineers did something that seemed to defy logic. They cut the parachutes away. On Earth, releasing a parachute means falling. But Venus is not Earth. The atmosphere near the surface is so dense, nearly the consistency of a fluid, that the module could break, using only a wide metal disc built into its structure, a ring-shaped flange that acted as an aerodynamic brake. The parachutes would have taken too long, dragging the lander through the killing heat for extra minutes it could not spare. So it fell freely, but slowly, the thick air resisting its descent like water resisting a sinking stone. The final descent took about an hour from entry to landing. As it dropped, the temperature outside climbed past 400 degrees, the pressure mounting toward 90 atmospheres. Inside the sphere, the lithium nitrate held the heat at bay, the interior still cool, the electronics still alive. The onboard systems counted down the altitude. And then, on March 1st, 1982, Venera 13 touched the surface of Venus. It settled onto a plateau region called Phoebe Regio, a plain scattered with flat, fractured rock. The ring-shaped shock absorber crumpled on impact, cushioning the landing exactly as designed. The module came to rest upright, stable, intact. It had survived the fall. Sensors immediately confirmed the conditions. 457 degrees Celsius, 89 atmospheres of pressure. The clock started. 30 minutes of guaranteed life, perhaps a few more if the insulation held. Every second now was borrowed against the rising heat. The machine had crossed 41 million kilometers and a decade of failed ancestors to reach this exact patch of orange rock. It was alive on the deadliest surface in the solar system, and its first task was to open its eyes. The cameras of Venera 13 were sealed behind protective covers, lens caps engineered to shield the optics during the violent entry and the acid-laced descent. Now, resting on the surface, the spacecraft fired the mechanisms to eject them. The cap sprang free and fell away onto the Venusian ground. It was a small motion, a few centimeters of movement, but it was the difference between a blind machine and a seeing one. And in one of the strangest accidents of the mission, one of those ejected lens caps landed directly beneath the drill arm, exactly where the instrument was about to sample the surface, a detail the engineers would only understand later. The cameras began to scan. They did not capture images the way a modern camera does. They swept slowly, line by line, building a panorama pixel by pixel as they rotated, feeding the picture up to the flyby stage and onward across space to Earth. The first data arrived line by line, assembling into something no human had ever seen in color. The world that emerged was orange. Not the gray of the earlier black and white Venera images, but a warm, sulfurous amber, the daylight stained by the thick atmosphere filtering out the blue. Flat slabs of fractured rock spread to the horizon, layered and broken, a landscape that looked at once volcanic and strangely ordered. Loose, dark soil lay scattered between the plates. The horizon curved away under a sky the color of a furnace. Venera 13 transmitted 14 images in total, including color panoramas covering roughly 170 degrees of the surrounding terrain. The color was not guesswork. The spacecraft carried a color reference chart mounted in view of the camera, letting scientists on Earth calibrate exactly what they were seeing. For the first time, humanity looked upon the true colors of another planet's surface, a hellscape rendered in living amber and stone. These were the most detailed pictures ever returned from Venus. But the mission was more than photography. As the cameras swept the horizon, another instrument was already extending toward the ground. A mechanical arm, tipped with a drill, was reaching down to bite into the surface itself. The panorama was only the beginning. While the cameras swept the horizon, a second mechanism stirred to life on the descent module's flank. A spring-loaded drill arm, armored against the 465°C heat, extended toward the ground and began to turn. Its titanium bit ground into the Venusian crust, chewing through rock beneath 90 times Earth's atmospheric pressure. The operation had to be flawless the first time. There would be no second attempt. No retry command from Earth 261 million kilometers away, where a signal took minutes to arrive. The drill bored to a depth of roughly 3 centimeters. Then a sampling system swept the loosened material into an intake port. This was the trick the engineers had labored over for years. How to bring a fistful of hell inside a machine that had to stay cool enough to think. The sample passed through an airlock and into a sealed chamber, isolated from the crushing exterior. Inside that vacuum-protected vault sat an X-ray fluorescence spectrometer, which bombarded the soil with radiation and read the wavelengths that bounced back. Each element sang its own signature. The instrument identified the rock as thol-iitic basalt, a volcanic stone chemically similar to the floors of Earth's oceans, rich in silicon, aluminum, magnesium, iron, and potassium. It was hard proof that Venus, for all its horror, was built from the same volcanic material as our own world. Other sensors measured the atmosphere directly. They confirmed a suffocating blanket of carbon dioxide, 96% by volume, laced with nitrogen and traces of sulfuric acid vapor. Instruments recorded the wind moving sluggishly across the plain at less than 1 meter per second, thick as syrup in that dense air. A gas analyzer sniffed for noble gases, hunting clues to how the planet had formed and lost its water. Every reading streamed upward through the orbiting bus, relayed back toward antennas in the Soviet Union. Bit by bit, a chemical portrait of another planet's surface assembled itself in Moscow. But each passing second carried a hidden cost. The heat outside was patient, and it was already beginning to find its way in. Venera 13 had been engineered to die at 32 minutes. That was the promise the thermal engineers made when they sealed the titanium sphere. Half an hour of function before the Venusian furnace overwhelmed everything inside. The design had a brutal honesty to it. There was no way to keep the interior cool indefinitely, no radiator that could dump heat into an atmosphere already hotter than a kitchen oven. The only strategy was to delay the inevitable. Before launch, the entire descent module had been chilled deep below freezing, packed with a lithium nitrate heatsink that would absorb thermal energy like a sponge. The interior began its life on Venus at a comfortable temperature, and the mission was a race against the moment that comfort ran out. But the clock kept ticking past 32 minutes, and the spacecraft kept transmitting. 40 minutes. An hour. The engineers, watching in Moscow, saw their machine outlive its own funeral. The insulation was performing better than the conservative estimates had allowed. Thick layers of thermal shielding wrapped the electronics, and the heat sink drank the incoming energy more slowly than feared. Still, the enemy never stopped advancing. Heat does not need a door. It seeps through every seam, conducts along every bolt and wire, radiates inward through walls no matter how thick. Degree by degree, the interior warmed. Inside the sphere, temperatures that had started near zero crept upward toward the limits at which silicon transistors simply ceased to function. The panorama cameras continued cycling. The instruments continued reporting. Data kept flowing upward through the orbiter, an unbroken thread of information from a place no human machine had any right to survive. The counter passed 90 minutes, then 100. Venera 13 had tripled its design life, then quadrupled it, transmitting a steady stream of measurements from the surface of a world that should have killed it in minutes. It was living on borrowed time, and everyone monitoring the telemetry knew the loan would be called. Somewhere inside that warming sphere, the first circuits were approaching their thermal ceiling. The final minutes had begun. "120 minutes after touchdown, the interior temperature crossed the threshold that no electronics could tolerate. The lithium nitrate heatsink was exhausted, its capacity spent, and now the Venusian heat poured in unopposed. Inside the sphere, components that had performed perfectly for 2 hours began to falter. Solder joints softened. Semiconductor junctions, designed for the tempered insides of a laboratory, edged toward the point where they stop switching current and simply conduct chaos. The telemetry arriving in Moscow started to show it. The clean, ordered stream of measurements grew ragged. Readings drifted. Channels that had reported faithfully for 2 hours returned values that made no physical sense, the signature of circuits cooking from the inside. The camera system, which had been methodically cycling its scans, could no longer complete a clean sweep. The transmitter, still pushing its signal up to the orbiting bus for relay to Earth, wavered as its power electronics overheated. Engineers watched the numbers degrade and understood exactly what they were seeing. A machine dying in real time, 261 million kilometers away, on a surface hot enough to melt lead. At 127 minutes after landing, the signal stopped. There was no dramatic failure, no explosion, only the quiet arrival of the inevitable. The last coherent packet of data crossed the void, was captured by the orbiter passing overhead, and forwarded home. Then, nothing. The descent module remained physically intact, its titanium shell still holding against the pressure, still standing on the orange plain where it had come to rest. But the thinking part of it was gone. The heat had finally reached everything. Venera 13 sat silent on the surface of Venus, a sealed monument slowly equalizing with its lethal surroundings. Its electronics fused into useless slag, its cameras blind. It would never move again. Never send another bit. Somewhere beneath the sky, the color of rust, the machine that had survived 4 times its allotted life became just another rock on a planet that destroys everything. But the signal it had already sent was traveling outward through space, and that signal could not be unmade. What Venera 13 had transmitted would outlast the machine itself, and outlast the men who built it. The machine was dead, but the data was immortal. In the days after March 1st, 1982, technicians in the Soviet Union processed the 14 images and reconstructed the color panoramas, and the world saw something no human eye had ever witnessed. A flat plain of fractured orange stone stretched toward a hazy horizon under a sky glowing amber. The sunlight filtered through 50 kilometers of carbon dioxide and sulfuric acid. Slabs of layered basalt lay scattered across the surface, and dark soil pooled between them. Part of the lander's own structure sat in the frame, along with the ejected lens cap it had flung aside to sea. These were not artists' impressions. They were photographs taken by a camera standing on another planet, in conditions that should have destroyed any camera ever built. The chemical analysis endured too. The conformation of volcanic basalt, the precise composition of the atmosphere, the measurements of pressure and temperature and wind, all of it entered the permanent record of planetary science. Venera 13 remains, to this day, one of the longest surviving landers ever placed on the Venusian surface, and its 127 minutes still stand as one of the great feats of engineering under impossible conditions. No spacecraft since has photographed that world in color. For over 4 decades, the images from Venera 13 have been the human window onto the surface of Venus, unmatched and unreplaced. The engineers who chilled its sphere, wrapped its insulation, and armored its drill had built something that did exactly what it was meant to do, and then far more. They aimed for 30 minutes and were given 2 hours. They aimed for survival and achieved sight. The lander still stands out there now, silent under that amber sky, a sealed tomb of fused electronics on a plane that has not changed since. It will remain for millions of years, long after every person who touched it is gone. But its purpose was never to endure as metal. Its purpose was to see, and to send that seeing home before it perished. Venera 13 did not die failing. It died, proving we could look.